All right. So today let's talk about circles in terms of their equations and their properties. Now, I need you to focus on this purple equation, and it's written as x squared plus y squared equal to 1. Notice that when I click on that, and this I'm using Desmos, notice that the graph will go away. But when I go back and click on that now, it gives me this purple graph that looks like a circle, and in fact it is a circle. So we want to play around with the characteristics and properties of a circle. First of all, from past, this is grade 2, 3, 4, 5. We know that a circle is created by tracing certain points that is always in the same distance from another point, which in this case is a center. We call it the center of the circle. And that distance, or that length between the center and all the points on the circumference of the circle, we call that distance the radius, or radii for many of them. Okay, now in this case, we have a radius of a circle from here to here is 1 unit, so that's 1. Notice that the up you go is 1, left, right, and in fact, if you choose any point on the circumference of the circle, doesn't matter where it is, if I choose any point, the distance between that point and the center of the circle must always be 1 unit. Okay, that's what this is. This is a circle given the radius of 1. Now, let's play around slowly with what happens when we start adding and subtracting values to the x coordinate and y coordinate and the x values and y values of the circle. So now what I'm going to do, I'm going to click on this second equation, and this black equation, what is happening is that I am now choosing a -1. I include a -1 in with the x, and then I square that. Plus y squared is 1. I didn't do anything to the y value, but the x value I put in there 1, or -1. But notice what is happening. The center went from 0, 0. Now the center of the new circle is 1, 0. Okay, the radius still the same. Notice that from 1, 0 to 2, 0 is 1 unit. So as you go up 1 unit, down 1 unit, and to the left 1 unit, and in fact any point on the circumference of the circle has the same distance to the center, which is 1. Okay, so this is a subtraction of 1. If you want to say that, that's okay. Now let's look at the second graph. This is a red graph. Now instead of the -1 to the x, I did x plus 1 all squared. And notice what happened. The graph shifted to the left. That means now the center is -1, 0. Exactly opposite of the value that is being added to the x. Do you see that, this one here? So this x plus 1, the center is -1, and then 0 is for the y coordinate. Now come back here. If I click on that one, you notice that for the first one, this is a black graph. It was x minus 1, but the center for x coordinate is +1. We didn't do anything to the y stayed at 0 because it didn't move up or down, so it stayed on the x-axis. So these values, when we add or subtract values to the x before squaring it, it shifts the graph left or right depending on what values we're adding. This is the horizontal translation for this specific relation, which is a circle. Okay, now we're going to deal with the vertical. So let me now unclick all of this horizontal translation. Now we're going to deal with only now the vertical. So I am now keeping the x value constant. That means the center, the x coordinate of the center will always be 0. So now we're dealing with the movement of just the y coordinate. Okay, so now notice y minus 1, the graph has moved up. The center now is 0. This is the center. If I can get the center right, 0, 1. That's the graph. Okay. The x hasn't changed, but the y went up. This is positive 1, but this says y minus 1. Exactly same thing. It's almost, it is opposite of what you see. If I click on the next one, you notice that the graph is dropping down. Okay, so here it is. The graph has dropped down, and this is the center of the other one, 0, negative 1. So here it is. When you add or subtract, and remember, it's always opposite of the value that you're doing. All right, where the center becomes that. In this case, the vertical movement is the vertical shift up or down. And notice that I didn't change the radius. Radius stays 1, but I could change the radius. I could change the radius. If I come here for the green graph, if I change the radius to 2, look what happened. It just becomes bigger. Okay, so so it's the square root of 2 is actually the radius, not 2. So if I actually put 4, now you will see that the graph is actually, and let me bring it down closer, you can see, now you can see that the radius is actually 2. Look at that. Look, this is the green graph. We're going from 1, from 0 to positive 2. And this is 4 we have written here. So square root of 4 is 2. That's the radius. If I put in 9, the radius is 3 now. Okay, so that's what is happening. So this constant value here, the square root of these constant values is the radius. So it just turns out the square root of 1 is 1, but the square root of 9 is 3 in this case. Or I can change that. Let's make that 4 so that I can see that one as well. Here we go. So that's 2, and then so forth and so on. So now put them all together. Let's look at the general or a standard form of an equation of a circle. An equation of a circle is given by this relation, x minus h all squared plus y minus k all squared equal to r squared, where h and k, the coordinate of the center of the circle, h, positive k, and r is the radius of the circle. Okay, and we can play around with this. Don't worry about the slider things here, but you can do the animation and go through that if you want to. But this is the standard form, and depending on what h and k is, the graph moves left, right, up, or down. And remember that is always opposite. So in this case, the center is h, positive k, but if this showed up x plus a number, then the center will be negative of that number. And so is the other one. All right. I hope that's helpful.